Hi everybody. Hello. How you doing? We're going to talk about how to add rationals. This is a super important thing you need to understand. Lots and lots and lots of my students have trouble with this in Math 100. I don't know why they didn't learn how to do it properly, but they didn't. So it's really important to me that you learn how to do it properly, because a whole bunch of things make a lot more sense if you know how to do this calculation properly. So at the end of this, you will be able to combine two rational expressions, adding them together. Okay, let's start. Let's start by talking about adding rationals. Oh, get out of here, denominator. All right, oops. Okay, so 2x plus 3 over x squared plus 4x minus 7 over x minus 1. When I say I want to add them together, what am I talking about? I'm talking about combining these two rational expressions into one big rational expression. I don't know what these polynomials, but the idea is you combine them and you get one polynomial divided by another polynomial. How do I figure out what those two are? The good news is it doesn't involve division in any way. The bad news is it still involves a little bit of thinkering. So before we do anything else, let's just illustrate what the problem is. Let's evaluate this at a point. Let's start by evaluating it. X equals minus 2. Okay? So this is 2 times minus 2 plus 3 divided by minus 2 all squared. And the second one is 4 times minus 2 minus 7 minus 2 minus 1. So this first numerator becomes minus 4 minus 1, and that becomes 4. And the second term becomes minus 15 divided by minus 3. And you know, we can simplify this a little bit. Boop, boop. Okay, good. So, how do I add those two numbers together? Try it yourself. Stop what you're doing and write what you get to combine these into one. If you wrote this, I want you to know that you need to pay close attention to what I'm about to tell you, because that answer is super wrong. Okay? It's wrong. It's wrong. It's wrong. It's wrong. It's wrong. It's wrong. Let me explain how it's wrong. Let me calculate its value. You calculate 15, so that's 14 divided by 7. That's 2. According to you, it should be 2. Like I said, not right. What do you mean not right? Let's just add these. I'll add them on my calculator. Minus 1 divided by 4 plus 15 divided by 3. What do you get? You get 4.73. It's not equal to 2. It's not equal to that. No! You understand? Long story short, you want to add these two together algebraically so that when you put in x equals minus 2, you get out this number. If you're not, then you're not algebraically doing it correctly. Okay? But that's not my only point. I mean, that was a pretty big point, and it was made very well, thank you. But it's not the only point. Another point I want to make here is that the problem of adding... because rationals kind of evaluate as fractions, the problem with adding rationals comes down to the problem of adding fractions. So how do I add these two fractions together? Well, we talked about that in a previous video. I would have to multiply this by 3 top and bottom, and I have to multiply this one by 4 top and bottom, right? And then you get minus 3 plus 60 divided by 12. So it's 57 over 12. Fine, that's fine. How do I combine these two? Well, I'm not going to get away with just multiplying this one top and bottom by 3, and this one top and bottom by 3, and then this one top and bottom by 4, and this one top and bottom by 4. I'm not going to get away with that. And the reason is that the particular values that I multiplied by here were numbers. There were these two denominators, right? And those two denominators are going to change as I change the value of x. So these two work for this particular value of x, but they might not work generally. So what am I going to do? If the name of the game is make the denominators match, why don't I just make the denominators match? What do I mean by that? I mean, why don't I multiply by polynomials instead of multiplying by numbers? Why don't I multiply the first one, top and bottom, by x minus 1, the denominator of the other one? Why don't I multiply this one, top and bottom, by x squared? And that way, the denominators are, well, they're new different polynomials, but the denominators are going to match, right? So then I expand the top, and I get 2x squared plus x minus 3 over x squared times x minus 1. And this one becomes 4x cubed minus 7x squared. And then I can, now that their denominators match and they've been simplified, I can combine them all together. The last thing I want you to get in the habit of is to sort your final answer. In this case, it's a perfectly fine polynomial. There are no repeated terms, but I like going from the left to right, largest to smallest. Oh wait, there's 2 more to cancel. 5x squared plus x minus 10 x squared x minus 1. All done. All done, you say? Why don't you test it? So the argument that I've just made is that 2x plus 3 the argument I have just made is that my original 2 rationals added together give me the same answer as times that. Okay? Let's test it. How about if we test for x equals 2? So the first one becomes 2 times 2 plus 3 over 2 squared. And the next one becomes 4 times 2 minus 7 over 2 minus 1. So that becomes 7 over 4 plus 1 over 1. And the other one becomes 4 times 2 to the cubed minus 5 times 2 squared plus 2 minus 10 divided by 2 squared times 2 minus 1. So this one becomes 4 times 2 times 2 times 2 minus 5 times 2 times 2 plus 2 minus 10. 4. Really? 4, 2, 2, 3, minus 5 times 4, plus 2. Oh, what? Did I make a mistake? Is that possible? Two x squared plus 3x minus 2x is 1x minus 3 plus 4x squared minus 7x squared So that becomes 4x cubed minus 5x squared plus x minus 10. Two, 4 times 2 times 2 times 2 minus 20 plus 2. What? I made some kind of mistake. How did I make a mistake? What is it? Did I copy these guys down wrong? Hold on. It's 4x 7 to 1. Dang it. Two times 2 plus 3 divided by 4. Nope. 2. Nope. 4. Plus 4 times 2 minus 7 divided by 1. Well, now my calculator broke. Oh, my calculator broke. Oh, jeez. Alright, let's start another example. My calculator broke. I'm pretty unhappy. Alright, how about if we do this one? 7x plus 1 divided by x minus 1 plus 4x over 2x plus 1. Okay, so the principle here is if the denominators don't match, you just need to multiply them by each other's denominators. 7x plus 1 all times 2x plus 1. That's the denominator of the other side. That's the original denominator. That's the denominator from the other side. And then we're going to multiply the right-hand one by the denominator of the left-hand one. X minus 1, x minus 1. All right, be careful when you multiply these things out. I'm going to be super careful. 7x times 2x plus 1 plus 1 times 2x plus 1. And this one is 4x squared minus 4x. So yeah, if you can find the mistake in the previous thing, I'll give you a present. Alright, so this one is 14x squared plus 7x plus 2x plus 1. And so you can add these two together because they have the same denominator. 4x squared minus 4x. And the result here divided by x minus 1 is 2x plus 1. And the result here is 18x squared. And then you cover all the x's. So it should be plus 5x plus 1. Alright, so let's try it at a certain value. At x is equal to 3. So it's 7 times 3 plus 1 divided by 3 minus 1 plus 4 times 3 over 2 times 3 plus 1. So it should be 22 divided by 2 plus 12 divided by 7. And this one here at that point should be 18 times 3 squared plus 5 times 3 plus 1 divided by 3 minus 1 times 2 times 3 plus 1. 18 times 3 times 3 plus 5 times 3 plus 1. 178 divided by 14. So 178 divided by 14 is equal to 12.714, and that's equal to 12.714. They're the same. Hooray, we did it right. We did this one right. Yeesh. Alright, so that's the method. You just have to make sure the denominators match. So to reiterate, so if you have one polynomial, p of x, denominator, plus another polynomial, divided by another denominator, we'll call it a. What you do is you take this polynomial, here, and you're going to multiply the top and bottom of that one by a. So it becomes px times a of x dx times a of x. So the value is going to be the same because you're multiplying here. These a factors of a would divide out. Qx over a of x, and then you take this polynomial here and you multiply this one top and bottom by the second one. Okay, so that's the procedure, and then you combine them, you add them together. It's fun. So it's not a big thing, but it's something worth being emphasized. Let me try that first one again. Ah, it's eating into me. All right, 2x plus 3 divided by x squared plus 4x minus 7 divided by x minus 1. So this first one becomes 2x plus 3 x squared times x minus 1. Oh, when you do it, you don't need to expand the denominator. I mean, you can if you want, but often it's really tricky to factor a denominator or factor a polynomial. So the result of multiplying the two together on the bottom is going to give you the factored form of a polynomial, and sometimes it's helpful just to leave it like that. Okay, so the first one becomes 2x squared plus 3x minus 2x minus 3, and that's going to be 4x cubed minus 7x squared. So that becomes 4x to the cube, and then minus 5x squared, and then so at x is equal to 3, this one becomes 2 times 3 plus 3 over 9, and this one becomes 4 times 3 minus 7 over 2, which becomes 2 times 3 plus 3, 9 over 9. And the second one becomes 4 times 3 minus 7, 5 over 2. And then this bottom one becomes 4 times 3 cubed minus 5 times 3 squared plus 3 minus 3 divided by 9 times 2. So it's 4 times 2, 3 minus 5 times 3 times 3. So that's 63 over 81. Nope, over 18. 3.5, and when you add these together, it's plus 3.5. Yay, I did it! I don't know what was wrong with the last time I tried this. Anyway, so have a good thing. Enjoy your life. Sorry you had to see me make a mistake.